Welcome to the final lesson of Unit 3, Lesson 8, Linear Models. So all this work we've been doing with these equations, it's to represent these problems that we might face sometime in life. Sometimes it needs to be very specific. But everything we do has a related function to a problem that you might see in the real world. We're not just doing these equations and these lines for fun. Because I know you wouldn't do these for fun. So, our first is you are buying hamburger and chicken. And hamburger costs $3 per pound and chicken costs $4 per pound. You only have $60 to spend. So you're going grocery shopping, you want to buy hamburger and chicken, but you only have $60 to spend on it. So we need to write a linear model and put that information in a table, just so we can look at it. Well, whenever we're doing these linear modeling questions, we need to establish what we want to call our x and what we want to call our y. So, let's say x equals the pounds of hamburger, and let's say y equals pounds of chicken. So we know we have our x and a y. What we now need to do is we need to put these in an equation. And that equation is going to be different for each problem that you face. Some of them are going to be in slope-intercept, some of them are going to be standard, and very rarely will they actually be in point-slope. The most common is slope-intercept and standard. And if we look at this, we know that we can spend a total of $60. And we know that total of $60 is going to equal our hamburger plus our chicken. And we need to put some numbers in front of our hamburger and chicken, and that is their price. We know that hamburger costs $3 per pound and chicken costs $4. So there we go. We now have a linear model to represent our problem. So what we want to do now is it's asking us to just put this info in a table to look. We're not actually going to pick or decide, which one do we want. We just want to kind of look and see what our options are. So, here's a table, and it's an XY table. So, let's just see what happens whenever we buy 5 pounds of hamburger. Let's see how many pounds of chicken we can buy. So, we would need to put in, we'd have to do some algebra. So 60 equals 3 times 5 plus 4y. So 60 equals 15 plus 4y. If we subtract 15 on both sides, we get 4y equals, is it 45? Okay, divide that by 4, and it looks like we get around 11 pounds of chicken. Alright. Well, let's say we wanted to buy 10 pounds of hamburger. Well, that's a lot. Let's not go up that much. Let's just say 6 pounds of hamburger. And then we'll do 7, then we'll do 8. So all we do is we do the same algebra again. So plug in a 6 here. So 60 equals 18 plus 4y. Do some subtraction. 60 minus 18 gives me 42. Divide by 4, and we get 10.5. Okay, and I'm going to pause the video and speed this up and fill out the table. Okay, and here's that table filled out. As you can see, here we're comparing the pounds of hamburger to the pounds of chicken that we could afford. And this question really isn't asking us to find something out, it's just look. Let's just look and see. So before we go to the store, we just want to see what our possibilities are. Alright, now let's go to another problem. This problem says a climber is scaling a 400-foot cliff. The climber starts at the bottom and climbs at a constant rate of 124 feet per hour. Write a linear model for the data. How long will it take the climber to reach the top? So this one we actually want to know an answer. We want to know how long it takes to get to the top. So I want you to go ahead and pause the video and work in your group and try to come up with your linear model and then how long it'll take for them to reach the top. So go ahead and pause the video and try that now. Okay, so the key thing here is that constant rate of 124 feet per hour. That's a giveaway. If you ever see something that says constant, think of the constant like your slope. So we have a slope, which probably means we're going to be in slope-intercept form. So let's let y equal the top of the cliff, and let's let x be the number of hours that we climb. So we know that y is going to equal 124x plus b. But what's b? Well, if we look, it says that we start at the bottom. Well, at the bottom of something is normally 0. So our b would be 0, so we don't actually need b. So now we need to look at our model that we now have. Alright. So y is the top of the cliff, and x is our number of hours. But we want to know how long it'll take to reach the top. How long means time. So it looks like we're going to be solving for x, which means we need to ask the question, do we know what y equals? And we do. We know that to the top of the cliff is 400 feet. So we can substitute in 400 in for y equals 124x, divide by 124, and we get that our x is going to be, let's just round it to the nearest hundredth, 3.23 hours. So it's going to take us 3.23 hours to reach the top. Alright, our last example for linear models. It snowed 12 inches on Monday. The weather warmed up and the snow melts 2 inches per day. So we need to create a linear model to show the data. And it should say how many days until the snow melts. So go ahead in your group, pause the video, and try to figure this out now. Alright. So we know there's 12 inches of snow, and as it warms up, the snow melts 2 inches per day. Well, that 2 inches per day kind of sounds like it's a constant. So we know we have a constant. So we know it's probably going to be something with slope-intercept form. So we're going to have y equals our x plus b. Well, our slope is our constant, and it's melting 2 inches per day. So we put a 2 here, except let's think about it. If something's melting, it's getting smaller. So if it's getting smaller, it's probably not going to be positive, it's probably going to be negative. So it's negative 2x plus b. Well, our b is going to be where we start, and the amount of snow that we started with was 12 inches. So our b is going to be 12. So here's our linear model, and we want to figure out how many days until the snow melts. So one way we could do this is we could graph it, or we could solve for our days of snow melting. And it looks here like x is the number of days. The way we have it set up, x equals our number of days, and y equals our amount of snow. So on the first day, there's 12 inches of snow. On the second day, there's so many. So what we need to do is we need to solve for x. And we want our amount of snow to be 0. So let's let y equal 0. So 0 equals negative 2x plus 12. And then we solve for x. Two negatives make a positive, so x equals 6 days. So in 6 days, all the snow will melt. That is the end of this lesson.